Hello. So I've noticed that the last video that I recorded was not doing a good job of keeping up with the video stream. I've adjusted some settings, and I'm going to make another attempt at this. But we're going to give you an update of the web scraper project. Excuse me. I want to start with an overview of what's happening behind the scenes. I know that I talk about a bunch of different pieces of this system, and sometimes it's a little bit hard to follow. So I want to loop back on an overview of what's happening here. Generally, the goal of this project is to allow users to interact with a web scraper and a Markov bot that will scrape the web for documents that are interesting to them and then produce Markov text from those documents that may produce some insights for the user. Additionally, I wanted to make that Markov text cited sources. So there are a bunch of little pieces that are involved in that. First off, we have Nutch. Nutch is a crawler program. This goes out and it finds web pages. It starts with a set of seeds that we give it, and then it follows links on those web pages to find other web pages that are related to our seeds. It takes those web pages, those documents, and it ingests them into Solr. Solr is a document index and search system. So we take all of those web pages that we found, we store them in Solr, we index them in some way, and then we have a search interface on top of that. Search interface is called loombot. So the crawler and Solr together comprise a basic search engine for the web. So we can get documents, we can search against those documents. The next thing we do, we query Solr to get a set of documents from our search engine, and we take those docs and we clean them. Cleaning means that we're going to take the text from the web pages and we're going to remove things that aren't interesting to return back to our users. In this case, our searches have mostly been focused on Wikipedia, so we do things like remove inline citations, remove references, remove see also pages, things like that. Once we have our text cleaned, we ingest it into what's called Bayesian network. We've discussed that here and there before. I'm not going to dig into it. Once we have a Bayesian network, we can query the network, or we can walk over that network to produce Markov chains. Markov chains are just the result of doing a weighted random walk over our Bayesian network and collecting up each of the tokens that exist in each of the locations of the network as we go. And the Markov text is what we end up returning to users. That's the Englishy text that they're reading. The new thing that we're adding in this demo is cosine similarity to select a best match. So to this point, our bot hasn't actually been doing any searching over the Bayesian network. We have been crawling the web. We have been ingesting documents into Solr. We have been using a leucine search to search Solr. But then we get those documents and we produce Markov chains, but we're not actually doing any matching against the Markov chains to see if they're high quality or if they're similar to what we're searching for. So cosine similarity is an algorithm that will compare some target text against the documents that we have in the Bayesian network, and I'll explain the algorithm here in a minute. And the new process here, we go through and we produce a set of Markov chains, and then we choose whichever one has the best match using cosine similarity to compare the target versus the Markov produced text. And then whatever has the best match is what we end up returning to the user. All right, so just a quick summary of that. We have Nutch crawling the web to grab documents that we put into Solr. We query against Solr to produce documents for our Markov bot. We clean the documents. We ingest the documents into the Bayesian network. We query the Bayesian network to produce Markov chains, and then we use cosine similarity to select the best match Markov chain to return back to our user. All right, let's hide this, and I'll show you what that looks like in code. Okay, so over here on the right side, I have a script that I call cosine comparator. Oh my gosh, the cat is having a lot of fun right now. So jealous. Okay, so cosine comparator is just a command line script that will demonstrate this cosine comparison process, and it allows us to interact with the matrix Markov class and the comparison mechanism on the command line. It doesn't need to be wired into the bot, so it's good for testing and development. All right, all this does, first off, we do our query against seller. We return some number of documents. Those documents are added into the Bayesian network here on the line 26. We recalculate the transition probabilities. None of this is new. The project's been doing that for a while. We have this get paragraph method. This is also not new. It does this process where we go out and get some number of Markov chains that we treat as a sentence, and it matches them together to make something that resembles a paragraph. And as it does that, it goes through and does this core part of the goals, where it tries to collect up the references that produced the Markov chain as it goes. Again, not new, but that's what's happening there. Dedupe and sort citations. It takes the citations that we collected, it removes duplicates, and then it just gives us the top 3 citations that produced our fake paragraph. Now here's the new interesting bit, cosine similarity. So the idea here is that we take 2 documents, we find all of the tokens that exist in either of those documents. So this is a big collection of unique tokens that are in either document A or document B. And then for those lists of unique tokens, we count the instances in either document. So target A is going to have some number of instances of each unique token, and the same is true for document B. So A and B have what we can represent as vectors, the vectors being the count of each unique token. And these vectors we can imagine these vectors existing in n-dimensional space, where n is the number of unique tokens that exist across these 2 documents. Then, what we do is we find the cosine of the angle between those 2 vectors that exist in that higher dimensional space. And that's all that's happening here. So we go through, we find the unique tokens, we count the tokens to form 2 vectors. That's target counts and compare 2 counts. Then those vectors are, we use NumPy. We turn these into NumPy arrays so that we can then do dot products and some math on them. That's all the math right here. At the end of this process, what we have is a cosine between these 2 higher dimensional angles. The higher the number for the cosine, the more closely these documents match according to this cosine comparison. This number is conveniently between 0 and 1, so it makes it easy for us to constrain it to some number of values. All right, so we have cosine similarity. It does a bunch of math. What we now need to do is compare some target text, something that we're searching for, against the Markov chains that are produced from the robot. So this is my static search string. I want to match against, in this script anyway, ionic sulfur impurities, and especially, but only in their chlorides. That's something that I pulled directly out of Wikipedia. So what we're going to do, we're going to produce paragraphs with our fake get paragraph method, and we're going to do that until one of 2 things happens. The cosine similarity score is above our target of 0.85, or we've run out of tries. We've exceeded our max number of iterations, and we have not yet gotten above our target score. So at the end of this process, we're going to return whichever paragraph is the best match. It's either going to be the first one that is above 0.85, or whichever one was the best score by the time we've reached 500 iterations. Pretty straightforward there, I think. And then lastly, we're just going to go through and print out some output. That'll look pretty similar to things that we've seen before. All right, so we'll demo this here on the command line, and then we'll pop over and show you the same sort of thing in the Markov, or excuse me, the Discord bot. All right, so some things to watch here. We're going to run the cosine comparator script. You'll notice that this runs a lot faster if you've been paying attention to how long it takes to build the Bayesian network. This used to take about 20 minutes to run on my computer here, a little bit faster on our server. Now it runs in about 20 seconds or so. So it's going to do that. It's really handy for real-time demos. It went out, it queried seller. We have 10 documents. They're loaded into the Bayesian network. Now you're seeing it do the cosine comparison process. Every time it finds something with a score that's higher than the previous best match, it prints out what the score is and which iteration it was found on. And as soon as it finds something above 0.85 right here on iteration 251, it's going to show us, just for the sake of comparison, the worst match paragraph. So this is the worst thing that it matched against the Bayesian network. And you can kind of see why. It's pretty illegible. And then the best match, oh wow, I can spell. The best match score is 0.85, and 73% by weight. Lithium demand for cobalt ores of paper were C and throat. I have no idea what that means. One thing to look for here is that it is a lot more legible in the sense that there is a lot less meta text. That comes from the fact that we're cleaning the text. It's also a lot closer to something that's English-like. This is partially the result of this cosine comparison process. So we're getting documents that are more similar to something that we would expect to be English language. But you're also noticing that I'm sure that it's still pretty much nonsense. So this is something where we kind of need to temper our expectations. No matter what we're doing with these machine learning algorithms, what we get is going to be gibberish as far as the algorithm is concerned. All we're really doing is pushing these things through increasingly clever sieves that make the output look more interesting to our human brains. So the next steps that we would take with something like this are applying something like a recurrent neural network to train our Bayesian network, or using transformers. Transformers are what ChatGPT and the like use. GPT stands for Generative Pre-trained Transformer, and that's based on this paper from Google AI called Attention is All That You Need. That's where transformers come from. Next steps for me are probably to start looking at transformers because I'm curious about how they work. I want to see if I can implement it. I don't know if it's going to be able to fit within the scope of this project, but we'll see. All right, that's enough waxing for me, but let me show you what this looks like as it's wired into the Discord bot. Let me show that window again. Hopefully in the video you're seeing our diagram outlining the pipeline for ingestion. I need to tab over to Discord, and we're spamming up Discord pretty bad today because I've recorded this video a couple of times, but I'll show you one more time. All the spams. All right, so search is now actually doing some search. That's pretty cool. What's something interesting to search for? Let's see. Why is the neighbor's cat chasing squirrels in my yard? Let's match against that string. Let's say show sources true. That was one of the core goals of the project anyway. And you'll see these two new options in the Discord bot, max rounds and target score. And these are exactly the same purpose as the max rounds and target score, or max iters and target score that I showed you in the code a moment ago. This doesn't quite work yet because these aren't being cast as float and int when they come in from the Discord input, so I'm not going to demo it. But what this will allow us to do is let users adjust how many rounds they want to run the cosine comparator and what target score they want to run it against. All right, so when I run this, you're also going to notice that the Discord bot can do this asynchronously. It's going to sit here and say the loombot is thinking or whatever while it's running the cosine process. All right, Loombreaker test bot is thinking. On the server where the bot is running, it's going to spit out some input that we won't see here, but eventually it finds a match. I think I set my target score at 0.85, and I think that I have max iterations at something like 50 right now, so that it'll return fairly fast. And when we search for why is my neighbor's cat chasing squirrels in the yard, we see list. See, the original response was first detected in excimer lasers for blue for synthetic element 14 atomic mass ejection by tracking them as a tri-suit inflation gas notation to uranium to be solidified by filling in S element, etc., etc. So this is pretty cool because it looks like English language and it's coming from our source query. The static query that we're running to build the Bayesian network right now is it's searching for documents in our index related to Argon. So we're only going to be able to match so close from that source material to this search string about cats and squirrels and whatnot. But it's pretty neat because it kind of looks like language, and we have some list of the citations and telling us where those documents, which documents contributed to that source. All right, so that's all I've got for you today. Excuse me, that's all I've got for the new material today. More general update for the project at large. Marcus has made really good progress on automating the crawler process so that we can change and adjust the seeds that Nutch uses to populate Solar over time. That'll help us keep the Solar index relevant, and eventually it'll allow our bot users to adjust the parameters that are being used to search and scrape the web. Zach is working on a REST API, which will hopefully allow us to build some user experience and some workflow around each of those steps that I discussed in this text pipeline. And Keelan is working on a Ionic app that should be able to interact with each of those processes as well. So you'll notice that most of my focus has either been on building back-end command line utilities or integrating that with the Discord bot. And the reason for that is specifically because that's where I'm interested, and that's the core functionality that I wanted to build. It doesn't make an application that's necessarily very usable. So these parts where we're looking at improving the relevance of the results with automation, or looking at building a REST API so that we can attach user-facing clients to it, or building user experience within a client, those are all really important for a project like this when we go out and try to demo it to other people and make it interesting for the world at large. All right, well, that's what I've got for you today. As always, hit me up on Discord if you're interested in chatting about this more. But bye.